All of these equations are written in what form? Standard form. So this is standard form. But if you're asked to find the roots of the equation, what are they asking for? What do the roots of the equation refer to? So that refers to the x-intercepts. Okay, so let me do the first one with you. In this question, x squared minus 9, what type of factoring would you use to factor this? Is it a trinomial? No. Is it a binomial?
Yes.
Are both terms perfect squares?
Yes.
So we're going to use difference of squares. So I want you to write it in factored form. It would be, what's the square root of x squared?
X subtract 3.
Take away 3 and plus 3, right? Because a positive and negative will get us back to a negative. So they've just repeated the function here. What would be the x-intercepts? How do you find the x-intercepts? You have to set each of the roots equal to 0, right? Because if y is 0, then x would be the x-intercept, right? Y always has to be 0 in order for it to be the x-intercept. So I'll write it out for you, but you can probably just look at it and figure it out. It would be x take away 3 equals 0, and x plus 3 equals 0. So what are the two x-intercepts? 3 and negative 3. So remember, these are in standard form. If you know the x-intercepts, can you find the axis of symmetry? Yeah, okay, so let's do that. You might need to do it on the back page. We know we can find the axis of symmetry. The axis of symmetry will give you the x coordinate of the vertex, right? And then we can use the equation to find the y coordinate of the vertex. So let's find the axis of symmetry. Okay, so 3 plus negative 3 divided by 2. 3 plus negative 3 is 0. 0 divided by 2 is 0. That's the x coordinate of the vertex. And we can use 0 and plug it in for x and solve for y. So y is equal to x squared minus 9. So 0 squared take away 9 is negative 9. This is not a difference of squares. I cannot find a common factor. It cannot be factored, which means that there are no roots of the equation. There are no x-intercepts. Is that possible? Think about it. What's the vertex? Where's the vertex located for this one? We can rewrite it as x take away 0 squared plus 4. I can rewrite it in vertex form. Where's the vertex? 0, 4, right? Think about it. It would start 1, 2, 3, 4. It would start right here. It does not have a stretch or compression. It's the exact same shape as the parent function. So it would go over 1, up 1, over 1, up 1, and so on. That's what it would look like. Does it have x-intercepts? No. So the x-intercepts of the graph, none. Okay, so the next one, we have to write this in factored form. You're looking for two numbers that multiply together to give you what? Multiply together to give you positive 4 and add up to positive 5. Positive 4 times positive 1 equals 5. So the roots of the equation are x plus 4 and x plus 1. What are the x-intercepts then? Positive 4? Negative 4 and negative 1. So we need to find the vertex. So we're going to figure out the axis of symmetry. So I'm going to add up the x-intercepts. So negative 4 plus negative 1 and divide by 2. What's negative 4 plus negative 1? What's negative 5 divided by 2? Okay, so I know that the x-coordinate of the vertex is negative 2.5. I need to figure out the y-coordinate of the vertex, so you're going to plug in x into the original equation. Look here. Use the original equation. We're trying to find y. So we're going to replace x with negative 2.5. Make sure you put it in brackets because it's going to become, what's a negative times a negative? And we're solving for y. You might want to do this on the back page. Okay, so negative 2.5 squared plus 5 times negative 2.5. So if the x coordinate of the vertex is negative 2.5, the y coordinate is negative 2.25. How would you write this in vertex form now? How would you write this equation? I know it's not on here, but I want to see if you can remember. It's y equals a bracket x minus h squared plus k. If you know the vertex, which variables can you replace? H and k, right? H and k. Does a change from standard to vertex? A is always the same. What is a in this question? 1. It's a 1, right? There's no stretch or compression. So what's the equation in vertex form? Y equals x plus or minus negative 2.5.
Plus.
Good. Squared plus or minus 2.25. Minus 2.25. Because k is negative. The sign doesn't change for k when you write it in vertex form. It only changes for h. You divided everything by negative 1, right? The common factor is negative 1, so you can rewrite it as y equals negative 1 x squared minus 4. So now that's a difference of squares. That is a difference of squares. But the equation is y equals negative 1 bracket x squared minus 4. I've factored out the negative. So will this parabola open up or down? Down. It has a negative 1. Can you factor this part? Can you find the roots of the equation? It's a difference of squares. So what are the roots of the equation? X, and it's take away 4. So it's a difference of squares. 4 is a perfect square. What is the square root of 4? And what times what gives us a negative? A positive and a... So those are the roots. X plus 2 and x minus 2. So the two x-intercepts are what? Negative 2 and positive 2. And this is similar to the first one we did here. Do we even have to find the axis of symmetry, plug it in, and find the y coordinate of the vertex? Or can you look at it and figure out the vertex? It's in fact, okay, the vertex is located at 0, positive 4, because if you look at the original equation, our k is a positive 4. For this question, this should say minus 6, okay? It has to be changed to negative 6. The greatest common factor is negative 2, so we divide everything by negative 2, and we're left with x squared minus 4x plus 3. Now we can factor this. We're looking for two things that multiply together to give us positive 3, and when you add them up, you get negative 4, right? So what are the factors? What are two numbers you can multiply together to give you positive 3? Multiplies together to give you positive 3 and adds up to negative 4. Negative 3 and negative 1 give you positive 3, and it adds up to negative 4, right? So x minus 3 and x minus 1. So what are the two x-intercepts? Positive 3 and positive 1. Now for this one, the original question was written in standard form. When we factored it, we still don't know the vertex, so what are we going to do to figure out the vertex for this one? Find the axis of symmetry, okay? So we're going to find the axis of symmetry by using the two x-intercepts. Add them together and divide by 2. So the axis of symmetry is x equals 2, which gives us the x coordinate of the vertex. How do I find the y coordinate of the vertex?
Plug that into the original equation.
Yeah, plug it into the original equation, which was y equals negative 2x squared plus 8x minus 6. Don't forget I changed it. And we're going to replace x with 2. Don't forget your brackets and BEDMAS. You have to simplify your exponents first. So this is first. 2 squared is equal to what? What's 2 times 2? So it's negative 2 times 4 plus 16, take away 6. Negative 2 times 4 is plus 16 minus 6 equals what? Y equals 2. So the vertex is 2, 2. So if you set each root equal to 0 and solve for x, then you're getting the x-intercepts, basically, right? So if the roots were x plus 3 and x take away 3, remember we did this? X plus 3 equals 0. So I know one root is negative 3, and x take away 3 equals 0. The other root is positive 3. So if you set them equal to 0, that's what you're technically doing. You're setting the y equal to 0 to find the x-intercept. So that answers question B. Why are the x-intercepts called zeros, Shavita? Because when y equals 0, that point is on the x-axis. Okay, so when y equals 0, that point intercepts the x-axis. That's why they're referred to as zeros. So we're looking at the x-intercepts and how it relates to the x-coordinate of the vertex. The x-coordinate of the vertex is the midpoint. That's the word I was looking for. Midpoint of the x-intercepts, which is, somebody else said it, the axis of symmetry. Okay, so to find the y-coordinate of the vertex, if you know the x-coordinate, you plug in the x value of the vertex into the original equation, and then you're solving for y. Okay, so there it is, and there you have it.